We now move on to transformations. In this, we will be discussing translations and reflections specifically. Okay. Firstly, let's look at translations in the y-axis. So you've been given a graph where the blue is the original function, and we want to end up at the red. And they've given us a point where what has happened is that the point has gone up how many units? 3 units, right? And so basically what's happening is that each point is going up 3 units. Each y value is going up 3 units for whatever the x value is. And for that, if you think about it, even logically, where if you had an x and that was giving you a y, we now want the y to be 3 units larger than what it was initially. So we want that x to give us a y plus 3, the same x, right? The same x, we wanted to give us a y plus 3. And therefore, if we had x, which is giving us f of x, so the function being applied to it, then what we want is we want the x to become f of x plus 3, right? And that's what we want, right? And for that, we just need to make this happen. So f of x plus 3 will just become x squared minus 2x plus 1 plus 3, which will end up becoming f of x plus 3 will be x squared minus 2x plus 4. And that's going to be the equation of the red line, which means now f of x plus a, okay, a general a, means translation, okay, of f of x, okay, by the vector 0, a. You know how vectors work, where if you have a positive at the top, so vectors work like this, x and y, where if you have a positive at the top, you go to the right. If you have a negative at the top, you go to the left. If you have a positive at the bottom, you go up. If you have a negative at the bottom, you go down. And so here, you're going up by a units, which means your vector will be positive a at the bottom. Yeah, the y will be positive a. Obviously, it doesn't move any by x. And so f of x plus a will be your translation of your original f of x by the vector 0, a. Next up is translations in the x-axis. So again, we have an original function, which is this one right here. Let me just color it blue so you can see it clearer. Okay. And we're moving it towards the red, towards the maroonish reddish one. And that is towards the right of it. Yeah. Specifically 3 units to the right. Now we can write this in vector format straight away, where this is 3 and 0, because it's not moving any direction in the y. It's just moving in the x to the right by 3 units, okay? However, it's gonna be a little different when you are looking at the function translation in terms of f of x. Now, for that, I need to explain something. So imagine we had an x, and that is going to an f of x. Yeah. Let's just say, for example, the x was 4, and we wanted it to go to f of 4. And what's happening now here, we still want f of 4, right? We still want f of 4, but we want the x value to be 3 units in front, right? And so we want the x value to be 7, but somehow we still want to put this through f and get f of 4 out of it. Remember, the only way you get f of 4 is if we start off by putting 4, right? Then you get f of 4. But we want to start off by 7, and we want to get f of 4 from that. And so what we do here is we will take 7 minus 3, which is equal to 4, and that would give us f of 4. So what we're doing here is we are taking now the x, okay, and we are subtracting it by a constant, okay, in order to get our original f of x. And so according to this, we have moved that same point. So suppose this this right here is f of 4. What we have done is we still want that f of 4, meaning we still want the same y value, but we want it to come at x equals 7. So what we do is we make the x as 7, okay, but we want to apply 4 into the function. So we would subtract 3 to that x. And so basically what's happening here is that your x turns into an x minus 3. Okay? Because you want to move 3 units to the right. And so here your f of x will just become f of x minus 3. And we can apply this here. So every x becomes an x minus 3, which means x minus 3 squared minus 2x minus 3 plus 1. And that's going to be your red function. Okay? And this might be confusing at the start because, again, you're moving it to the right, but you are subtracting the constant. You're not adding the constant, which you did with the y. But if you look at it how I have explained it here, as to why we have to subtract instead of add, it will make sense with more practice. Okay? And so your red function right here is just going to be x minus 3 squared minus 2x minus 3 plus 1. And so f of x minus a, okay, if you minus a value, this will be translation, okay, of f of x by vector a 0. So you're moving it to the right still. Yes, you're still moving it to the right. Next up, let's look at reflection in the x-axis. So if you see what's happening here is that a certain value of y, which is 4, okay, here, is becoming negative 4 here. The x is still the same. The x is still 3. So when x is 3, x is the same. What's happening is that y, which was 4, is becoming negative 4, which, if you take reference to the original one, will just be negative y. And so what we're doing here is we're applying the negative to the y. And remember, the y is just the output, which is f of x, meaning you apply the function to x, you get y. And so for a reflection in the x-axis, your f of x will just become negative f of x. Okay? And so your x squared minus 2x plus 1 will just become negative of x squared minus 2x plus 1, which will become negative x squared plus 2x minus 1. And that's going to be your new equation with the reflection. So if you have negative f of x, that is a reflection of the original f of x in the x-axis. So the reflection is in the x-axis. The x-axis is acting as a mirror. Okay? Next, we look at reflection along the y-axis. And here what's happening, we can take any point. Let's just take this right here, which is negative 1, and this is positive 1. The y value has stayed the same. So when the y value is 0, this has now gone from negative 1, which was originally x, and it has now become positive 1, which is now the new x. Okay, let's just call it xn for new. And if we want to show xn in terms of this x, our new x is just negative of the original x, meaning negative of that negative 1, which will give us a positive 1. Meaning whatever value of x you had initially, what you're doing is you're just changing that x into a negative x. That's it. So if you basically it's changing the sign. Yeah. So if this was at negative 2, then it's going to be at positive 2. If this was at negative 3, then this is going to be at positive. If this was at negative 3, then this is going to be at positive 3, and so on. Right? And so you're reflecting it along the y-axis. So this is what happens when you are reflecting along the y-axis, meaning f of x will just become f of negative x. And as per this, remember your x's are all turning to negative x's. So negative x squared minus 2 negative x plus 1, which is just going to be again x squared plus 2x plus 1. Okay? And that's what's going to happen. So whenever you want to reflect you have f of negative x, which is the reflection of y equals to f of x in the y-axis. And that's going to be the reflection part covered. Now let's go look at some examples. First one is about translation. So the graph y equals to x squared plus 5x is translated 2 units to the right. Remember, whenever we're moving 2 units to the right, we are looking at an x translation, meaning it's going to be x turning into something, and we want the equation of the resulting graph. So first we need to find out what exactly we're doing. So x is becoming x minus 2, because remember the unit vector is 2, 0. And for x's, remember you will subtract because I explained you the whole part previously. And so your x is becoming x minus 2, which means your f of x will just become f of x minus 2. And so what will happen here is your y equals to x squared plus 5x will just become x minus 2 squared plus 5x minus 2, which will be x squared minus 4x plus 4 plus 5x minus 10, which will equal x squared plus x minus 6. And that's going to be your original function after it has been translated 2 units to the right from the original x squared plus 5x. So it moves from here up to here. Then the second one, the graph of y equals to 2x is translated by the vector negative 5 and 3. So what's happening is it's moving to the left by 5 units, and then it's moving up by 3 units. And according to our transformation that we have done, the translation part, it will be x will become x plus 5, because plus now is moving to the left, because moving to the right was a minus. And then we have our y becoming y plus 3, as we said. That just moves up 3 units. And we're going to apply both of these to our original f of x. So what's going to happen is f of x will become f of x plus 5 plus 3, the entire thing. Okay, and we can do that here. So y equals to root 2x. Now your x is becoming x plus 5, and then you're adding 3 at the end. So y will equal to root 2x plus 5. Then you're adding your 3 at the end. And that's going to be your answer for your translation, negative 5, 3. Finally, let's look at the reflection example where the quadratic graph y equals to f of x has a minimum point at the point 5, negative 7. Okay, just right, 5 and negative 7. And we want to find the coordinates of the vertex and state whether it is a maximum or a minimum for each of the following graphs. So y equals to negative f of x. What's happening is that your y value is becoming a negative y value, right? And so if you think about it practically, if we had something like this, it would end up becoming something like this. Yeah, because if this is the y-axis, what's happening is that this whole thing is coming down. And so remember, our x value stays the same. It's only our y value that changes, meaning our x value stays the same, y value changes over sign. So 5 and 7 now, which will now be a maximum, because the original one was a minimum. So this is going to be a maximum. Okay. And the second example, y equals to f of negative x, which is a reflection along the x-axis, meaning if something is here, it will just move here. It will just reflect along the x-axis. It will still be the same graph. Whether it's positive, it will remain positive. This negative is going to remain negative. What happens is it just moves to either side of the axis, meaning it uses the y-axis as a mirror. And here what's happening is that your x value is becoming a negative x, but your y stays the same. So if you look at the original 5, negative 7, what's happening is it becomes negative 5 and negative 7. But it will still be a minimum because the shape of the graph does not change. So it's going to be negative 5, negative 7, and it's going to be a minimum. And that is it for reflections and translations.